Dear students, good morning, namaste. It is a third part for the PU2 coaching classes, mathematics. Third part, that is we are in the synopsis of a straight line. In the synopsis, first 10 is over. The 10 also, it is finding orthocenter and circumcenter. There are 5 centers are there. Those 5 centers, you note it now. One is centers, centroid. It is centroid, that is denoted by G. Second one is orthocenter. It is orthocenter. Okay, na? It is orthocenter. It is denoted by capital H. Third one is circumcenter. Circumcenter. It is denoted by S. Fourth one is in-center. Okay, na? In-center. It is denoted by capital I. Fifth one is excenter. Excenter. It is denoted by I1 or I2 or I3. It is also centroid. Okay, now see the 5 centers. Listen with it. Centroid is a point of concurrent of medians. Okay, now medians. Whereas orthocenter is already I told you, orthocenter is point of concurrent of altitudes. Altitudes means perpendicular drawn from vertices AD, BE, and it is CF. Like this. It is BE, CF, AD. Altitudes. They meet at one point. That point is orthocenter and it is denoted by capital H. Circumcenter. Circumcenter is the point of concurrent of perpendicular bisectors. Perpendicular bisectors. That means you say SL is a perpendicular bisector of the sides. SM is another perpendicular bisector. Of course, NS is also is there, but not needed to write. Of course, I will write it. Okay, now it is a perpendicular as well as bisector. Bisector means it is passing through the midpoint. Here L, M, N are the midpoints of sides. But here D, E, F are not the midpoints of sides. They are the feet of the perpendiculars, altitudes. Okay, now a lot of difference is there. This SL will not necessary to pass A or SM not necessary to pass B. Okay, na? That is point of concurrent of perpendicular bisector, point of concurrent of altitudes, and it is point of concurrent of medians, centroid, and in-center. In-center is the point of, see I will draw here, it is a point of concurrent of angle bisector, internal angle bisector. Okay, now it is say AP, it is BQ, it is a internal angle bisector. It will meet at one point. That point is called as in-center. So in-center is the point of concurrent of internal angle bisector, AP. It divides this angle A into 2 parts, equal parts. CR or BQ, they are internal angle bisector. They meet at one point, that is in-center. And hence X-center is one internal angle bisector, the other are 2 external angle bisectors. I will draw again. That is denoted by I1, I2, I3. There are 3 notations are there. You may get some doubt. I1 is the excenter opposite to the vertex. It will come here. I will tell again clear. I is related to B. I3 is related to third vertex C. Okay, leave it out. Now we'll come to the point. Here we are finding the orthocenter. It is a very important concept. Here x1, y1, x2, y2, x3, y3 are three vertices of triangle. Their numbers 1, 2, 5, 8, 9, 10 like that. They are numbers. By using those numbers, you see x of x1 minus x2, y of y1 minus y2. Here x and y are variables, whereas x1, x2, y1, y2 are numbers. If you simplify, it may be 3x plus 4y like that. Here also x3 of x1 minus x2. x3 is number, y3 is also number. The coordinates of third vertex. If you simplify, we will get some number 5. Suppose 3x plus 5y is equal to 6 like that. If that equation satisfied by the given 4 options, out of any one of the 4 options, suppose this question is asked in the objective. There are, we are given 1, 2, 3, 4, 5, 6 are vertices of triangle. And we are asked to find the orthocenter. Okay, now, at the time we use this 2D equation. We will get one equation. And also for this question we are given the 4 options. Only one of the 4 options satisfies this equation. Which satisfies that equation. That option is the orthocenter. That is the, what is the reason? It is not needed. The proof is not needed. Okay, na? That is. With one example we will clarify. And we will come to the circumcenter. Circumcenter. Finding the circumcenter. Same x1, y1, x2, y2, x3, y3 is taken here also. You see, Nana? Okay, now. Here you see 2x of x1 minus x2. 2y of y1 minus y2 is equal to x1 square plus y1 square minus x2 square minus y2 square. I am neglecting one vertex. Only with the help of 2 vertices, I made one 2D equation. In the orthocenter, x, y comes. But here in the circumcenter, 2x, 2y will come. Okay, now only 2 vertices. Third vertex is not mentioned. With the help of 2 vertices, we get 2D equation. If this equation, after simplifying, they are the numbers, only x and y are the variables. They are the numbers only, coordinates. After simplifying this one, we get one equation. That equation is satisfied by any one of the 3 vertices, 4 options. That option is called the circumcenter, which satisfies this equation. Out of the 4 options, that option is the circumcenter, yes. Here, orthocenter. Okay, now it's very clear. Now I want to give the one example. Through that one, we can clearly understand how to we find this one. This is part, I think, 4. One example. You see, it is part 4. Observe well. Orthocenter is one example. With example, we can find both the orthocenter and the circumcenter. You see, this origin x, y axis. Here is, we will take one right angle triangle. It is 3 units, it is 4 units. So this is 1, 1 unit, 1, x1, y1, 1, 1. and it is parallel. So B is also, so 1 unit distance y coordinate is same 1. But in order to get 4 length, it is 5. 5 minus 1 is 4. Okay, na? Same. But see, the x coordinate is 1. But in order to get 3, it must be 4. Now it's okay, na? Okay, na? Like that. With our own, we will take one triangle. Here, it is a right angle triangle. 3 units, 4 units means it is 5 units. Okay, na? In a right angle triangle with the given vertices, you see, actually, orthocenter of right triangle, we know that it is right triangle, is the vertex. Is the vertex, okay, na? Is the vertex at right angle. Right angle means 90 degrees. At 90 degrees, the vertex is A. So here it is orthocenter is only A. It is 1, 1. We know it. It is also one concept to remember it. In right angle triangle, the vertex at right angle is the orthocenter. We know it well. In the mensuration it is there. And here, one more thing. Circumcenter. Okay, na? Circumcenter of right triangle, same triangle, ABC, is midpoint of hypotenuse. So S is equal to, here it is H. Here S is equal to, circumcenter notation, S is equal to the midpoint of hypotenuse. This is hypotenuse. And 5 plus 1, 6 by 3 means, by 2 means 3. 4 plus 1, 5 by 2. So this is a circumcenter, we know it. But in object, we don't know whether it is a right angle triangle or a equilateral triangle, we don't know. A triangle is given. The same question we will solve with the 20 method. Of course, it is also there. If it is right angle triangle, okay. But in a different way, we will do. Suppose 20 equation. What is 20 equation for the orthocenter? It is x of x1 minus x2 na, y of y1 minus y2 na is equal to x3 of x1 minus x2 plus y3 of y1 minus y2. X of, so I am taking this one, B and C. It is x1 y1 and it is x2 y2. Just so it is 5 minus 1 y of 1 minus 4 x3. Let it be. This is x3 y3. Sir, here is x3 y3. You may get some doubt. Whatever it may be. This is only name sort. You change any or take this x1 y1 x2 y2 and x3 y3. Or otherwise this one, this is x3 y3. Whatever it may be, you take it. But here it is 1 of 5 minus 1 plus 1 of 1 minus 1. This is 4x minus 3y. It is 4 minus 3. 4 minus 3 then. It is 1. 4 minus 3, 1. So this is a 20 equation. Suppose option is 1. It is say 1 comma 1. Second option maybe 5 comma 1. Third option maybe 1 comma 4. Fourth option some none. Which one is satisfies this equation you see there? I am taking here only. These are the points only. You take anything. Here satisfies only this one. Suppose 5 comma 1. 4 into 5. 20 na? 20 minus 3, not 17. 1 is there. We take this one. This is 4 into 1, 4 minus 3 into 4 is 12. 4 minus 1 minus 8 will come. So this is wrong. If fourth option is other than none, any number is given, not possible. Except only 1 comma 1. 4 into 1, 1 minus 3 into 1, 3. 4 minus 3 is equal to 1. 1 is equal to 1, satisfied. So only 1 satisfies. What is this option 1? 1 is nothing but orthocenter is already is there. So this one. Okay, if the triangle is right angle triangle, we can understand. But how can you say it is if it is not given 90 degrees is not given, this diagram is not given, directly the orthocenter of the triangle whose vertices are 1, 1, 5, 1, 1, 4 is given. How can we find it is right angle? By using this one, it is very easy. If you know it is right angle triangle, then the vertex at right angle is orthocenter. The midpoint of hypotenuse is circumcenter. Who can understand? Okay, na? So this is the method. It is a very good method. Without knowing the triangle is equivalent triangle or isosceles triangle or right angle, whatever it may be, we can use this one. This method is very useful. Okay, na? Only one option will satisfy that equation. Okay, na? Here only one more thing. Suppose another one is there, one more option is there to satisfy this equation in these options, 4 options. At that time, by changing the x1, x2, okay, na? Here I am taking B and C are x1, x2, y1, y2. I mean x1, y1, x2, y2. Just you change. Equation is same. You change this one. At the time we can another equation will get. Do you understand it now? Here I am taking x1, y1, x2, y2 as B and C. You take x1, y1, x2, y2 as A and B. C is x3, y3. Then we can get another equation. Okay, na? At that time, the two equations satisfies by only one option. Not doubt at all. That two options will not satisfy. That is not. It is not possible. So at that time, it can be filtered. But mostly in the CET, only this type of questions will ask. Okay, na? Right. Okay. Next, here only, I want to tell the circumcenter. Okay, na? Here only I will do. See, same question. The triangle, we know it. It is actually the midpoint of hypotenuse is 3, 5 by 2 is there. We use the 20 method. 2x of x1 minus x2, 2y of y1 minus y2, and it is x1 square plus y1 square minus x2 square minus y2 square. This is for circumcenter, to find the circumcenter of the triangle, this triangle. It is 2x of, what is x1, x2, same, you take it. It is 5 minus 1, 2y of 1 minus 4, it is 25 plus 1, okay, na? x1, y1, x1 square, y1 square, minus 1 square minus 4 square, 16. Here 1 cancels, it is 25 minus 16 is 9 1. Here 4 2 is 8x. Here minus 3 minus 6 y. Okay, na? So here the only equation is 8x minus 6y is equal to 9. This equation satisfies by any one of the 4 options. First option say 1, 2. Second option is 5, 1. Third option is say 3, 5 by 2. Fourth is some 1, 4. Okay, na? It is 1, 4. 4 vertices and the midpoint also is given. That is the correct answer. You take see 1, 1. Can you satisfy this equation? 8 into 1, 8 minus 6 into 1, 6. 8 minus 6 is 2, not 9. So this is wrong. It is 5. 8 5 is 40 minus 6 into 1 is 6. 40 minus 6 is 33 not. This is also not correct one. We take fourth one. It is 8 into 1, 8 minus 24. 8 minus 24 minus 16. It is also wrong. So only this one is. It is, see, this one. It is 8 into 3 na. Minus 6 into 5 by 2 na. It is 24 minus 2, 3 is 3, 5, 15. 24 minus 15 is nothing but 9. Is correct? So this is correct. Okay, na? Here is the, this is the circumcenter. Okay, na? By using this method, 20 method, we can find the orthocenter or circumcenter. Okay, na? Is it clear? No? Yeah. Thank you. First. Okay. Observe. Then the last topics in the synopsis is also very important synopsis points. That is, we are given the vertices of a quadrilateral. Quadrilateral means only having 4 sides. Whether that quadrilateral is a square, a rhombus, a rectangle, or parallelogram, we don't know. But a question is given. It is asked. 4 points given, 4 vertices given. Here, for the purpose, I wrote only a rectangle. It may be a parallelogram or a rhombus or just a question. Okay, now, it is a quadrilateral. We are given 4 vertices, 1, 1, 7, 8, 9, 10, 10, 11, like that, 4 vertices given. We don't know. How can you verify? A raw method is there. Finding the lengths of all sides and diagonals lengths. If all sides are equal and diagonals are also equal, then it is called as a square. Okay, now? If all sides are equal, diagonals are not equal, it is a rhombus. Opposites are equal. Okay, now? Diagonals are also equal, then it is a rectangle. Like that, it is a raw method. But simply vertices given, we have to verify whether it is a square or rhombus or something or something. At the time, the raw method is not a suitable one. It takes at least 5 or 6 minutes. But we are given only 1 minute. So, the best method, a 20 method is there when we are given with the vertices. It is a 20 method is there. That 20 is telling that, let suppose capital X is the slope of AB and slope of AD. Slope of AB is finding the difference of y coordinate is very simple. 5 minus 3, 2 minus 1 like that. 1 comma 2 something and something is given numbers. We can easily find the slope. Slope of AB into slope of AD. So that product is there. Let y is equal to slope of AC and slope of BD. It is also very simple. Within the seconds we can calculate. If that x, that means the product of slopes of adjacent sides, and y is the product of slopes of the diagonals. If they are equal to minus 1 and minus 1, x is minus 1, y is minus 1 means it is perpendicular, it is also perpendicular. Okay, now? The diagonals perpendicular, adjacent sides are perpendicular means only in the case of a square it is correct. So, x is equal to minus 1, y is equal to minus 1 means it is square. It is a matter of 20 seconds, we can easily. If it is x is equal to minus 1, y is equal to minus 1, square. If x is equal to minus 1, y is not equal to minus 1 means it is rectangle. In the case of rectangle, only the adjacent sides are at right angle, but diagonals are all not right angle. So, it is very clear. If you find x and y, both are minus 1 square. X minus 1, y not minus 1. It may be something, whatever it may be. It is a rectangle. Or otherwise, x not minus 1, but y is equal to 1. That means, here the adjacent sides are not right angle, but diagonals are right angle. Then, it's very simple. I will tell clearly, with the diagram you can understand. You see, first one, square. in the square like this, adjacent sides right angle. Diagonals are also right angle. These diagonals are also a right angle in the case of square. Okay now? Whereas in the rectangle, you see, this is a rectangle. It is a length. Length. Here, adjacent sides are a right angle, but diagonals are not right angle. It's a curve. It's a 90, it's a 90 and another angle. The rhombus is like this. The adjacent sides are not right angle, but the diagonals are at a right angle. Okay na? Very clearly is given. Okay na? Like this. And parallelogram. Parallelogram means like this. You see, in the parallelogram, it is not right angle, and the diagonals are also not a right angle. Like this, we can take that concept and we can draw this one. We are using this one. X and y both are -1 square. X only -1.